Hello dear viewers, today I will be starting with these three analogies for today's topic. They are shown as three stages of mind when I enter a grocery shop. The first grocery shop where I go, the first stage, is where I have only 100 rupees note. And that 100 rupees I'll use to buy something from this shop. Then I have nothing left to buy something from this shop. In the second stage, I have 200 rupees note where I go to the grocery shop, I buy something worth 100 rupees and I'm left with 100 rupees to buy something from this shop. And in the third stage, I have two 500 rupees note and I go to this shop, but there I find two friends of mine where one friend is angry on me because he wants the 500 rupees note back that he had given to me. I had borrowed from him, so I have to return it to him. And the second one is sad and he urgently needs 500 rupees to buy something from that shop, so I give him 500 rupees. Now I'm left with nothing, but I have produced a pair of two happy people. So this is the basis of today's different methods or different interaction of the nuclear radiations, the gamma photons with the matter. That is the photoelectric effect, Compton effect, and pair production. So let us start with the contents. What are the photons? What is the significance of today's topic? What is photoelectric absorption, Compton scattering, and pair production? What are photons? They are electromagnetic radiations of zero mass, zero charge. They are neutral. That means I'm traveling with the speed of light and highly penetrating packets of energy. The significance of today's topic is that they are the principles of the radiation detector. They are the basis of therapeutic action of these nuclear radiations on matter, on the cancerous tissue for that matter. And planning or shielding of the nuclear radiations to protect the radiation worker, that can be planned according to these interactions. If you know about how much will be the interaction, how serious will be that, accordingly the shield can be planned. Now, what is photoelectric effect? It is a complete energy transfer when an incident photon packet of energy loses all its energy in that matter and an electron is ejected. It is predominant at low energies, less than 100 keV or 0.1 MeV, and is more in the high atomic number matter or the absorbers. So lead becomes a very good shielding material for radiation protection. These lead bricks you can see here, which are used to protect the radiation worker from the open sources which are kept behind these lead bricks. Now, when energy of the photon is just more than binding energy of the electron with which it interacts. Now, what is Compton scattering? It is, yes, the partial energy transfer when the incident photon loses some energy that ejects loosely bound electron, leaving the medium with lesser energy as a scattered photon at a deflected angle. These Compton scattering effects are predominant at energies more than 0.1 MeV but less than 10 MeV, mega electron volts. Most dominant in the tissues, and the gamma is deflected through an angle theta, and all angles of scattering are possible. Now, what is pair production? So this is where energy gets transferred to matter. when a very highly energetic photon interacts with the atomic nucleus, occasionally with an electron inside the medium, due to which it gets converted into a pair of positron and its antiparticle negatron, E plus and E minus. It is predominant at very high energies, more than 10 mega electron volts. Each of the pair E minus and E plus will have a rest mass equivalent to 511 keV or 0.511 MeV. Hence, the photon energy has to be more than 1.02 MeV. E0 minus 1.022 MeV, that is, E0 stands for the energy of the gamma photon, which will be the whatever is the difference between these two will be imparted as a kinetic energy to E minus and E plus. Now this is a schematic diagram of the photoelectric Compton and pair productions methods of interaction of this gamma energy to the matter, and here where gamma is in and electron is out, there is no any extra gamma left, while here gamma is in and the deflected gamma and along with the electron also out. And here in the pair production, it is the gamma getting very close to the atomic nucleus, and there is a pair of electrons or pair of positron and negatron produced, with the gamma getting totally destroyed or annihilated, because this energy has got converted into matter. Now here in this graph you can see the graph of atomic number of the absorber versus photon energy MeV. As the atomic number increases, photoelectric effect increases, but it is within the it is at lower energies, while Compton effect is dominating between 0.1 MeV to 10 MeV, and as the MeV increases beyond 10, it will be pair production which dominates. So the summary is, what are photons? What is the significance of this topic? What are the different interaction methods? Photoelectric absorption, Compton scattering, and pair production of these gamma photons with the matter. Now in the part 2, I'll be talking about the interaction of alpha and beta particles with matter, that is ionization, excitation, bremsstrahlung, and annihilation. So let me leave you with this slide where I am waiting for your questions, if any, and hopefully that you have liked this nuclear physics topics that I have shown to you. Thank you.